So we use the SI system, or the International System for units, and we use in chemistry what we call the MKS system, which is meter, kilogram, second. Those are going to be our standards for what is our base units for all the things. All right, so if we measure in lengths, we measure that in meters. If we're measuring mass, we measure that in kilograms. Now, in chemistry, we're often going to be measuring masses in grams and also milligrams because they're very small quantities of things. But the standard unit is kilo, it's kilogram. Time is measured in seconds, and temperature is measured in Kelvin. And so one thing that we'll need to know is the relationship between Celsius and Kelvin. Most thermometers that you go to the lab will be in Celsius. So to convert, we can say that Kelvin is equal to Celsius plus 273.15. And you'll learn a little bit more about that in a later chapter. But that is just a separate temperature scale that we can use that doesn't have negative values. All Kelvin temperatures are positive. So like I said, a lot of these links, we don't actually use that, right? If we're measuring things, we're going to use something like maybe centimeters or millimeters or maybe grams or milligrams. Or some things happen on the scale of nanoseconds. And so we have to really understand those metric prefixes that we've talked about in the past to be able to understand what's going on. That is a have-to thing, okay? Understanding those metric conversions is a have-to thing. Good. So again, here is that metric prefix table. If you want to take a picture of this so you don't have to write all this down, go for it, okay? It's in those notes that I've posted in Canvas, so you can pull it up there too. But we want you to understand this. We want you to know when I say, kilogram, that kilo is modifying the base unit gram. And what that means is when I say kilo, you can directly replace that with this 10 to the 3, right? That's why we like the exponents over there. That's one of the reasons. The other reason is it makes the math really simple when you're dealing with those powers of 10, because you can add and subtract those powers of 10 when you multiply and divide. It makes the math nice and simple, okay? But we need you to understand these and know these. You're going to have this kind of stuff on exams, okay? This is a have to remember, have to know thing. So how do you know which one to use? Well, humans do really well with numbers that are somewhere between 1 and 1,000, right? We can grasp those numbers pretty well, right? If I tell you 26,315,000, do you have any concept of how many that is? Not really. Humans don't really grasp that large of a number, okay? But if I tell you 258, we can kind of visualize what that might be, right? So when we're picking prefix multipliers to talk about stuff, we want to pick a multiplier that gives us a number somewhere between 1 and 1,000, right? So I can say something like 1,500 milligrams, right? Or something like 840 kilograms, right? I wouldn't want to report that in centigrams. So you want to pick a unit that's close to the size of the thing that we're talking about. So here's an example, right? So a chemical bond is about 1.2 times 10 to the minus 10 meters. What would be the best unit to use in order to represent that number? Because we have a hard time understanding what that number means, right? So our choices, let me give you some choices here. We could use micro, which is 10 to the minus 6. We could use nano, which is 10 to the minus 9. We could use pico, which is 10 to the minus 12. We could use milli, which is 10 to the minus 3. What are some suggestions? Say again. Nano. All right. So if we use nano here, then this would be 0.12 nanometers. All right. if we used pico, it would be 120 picometers. If we used micro, it would be 1.2 times 10 to the minus 4 microns. If we used milli, it would be 1.2 times 10 to the minus 7 millimeters. Which one of those numbers is most friendly? That one, right? So if we were just reporting this number, if we were writing this number down in a paper somewhere or something like that, we would most likely pick picometers because it represents the number then in a reasonable fashion. Okay? Does that make sense? You guys grasp that concept? We pick the unit that gives us a number that is a tangible number. Okay? And that's not a have to. You're not going to get stuff wrong if you report it as 0.12 nanometers. It's still the same number, right? It's just convention says we want to use the one that makes the number easy to read. Okay, so here's a question for you guys. So for me, it helps if I go ahead and put it in scientific notation. So can you help me put this number in scientific notation first? What would we get? 7.50 times 10 to the, it's going to be negative because this is a small number. And then how many times do we move the decimal place? 4. And the unit on this right now is meters. So what's the easiest way to convert? That's a 4, by the way. That doesn't look like a 4 on your TV screen over there. There you go. So what's the easiest way to make these representations? Well, so let's just pick one. All right, you guys pick a unit, and let's figure out how to make the conversion from what we have to that unit. Okay, so what unit would you like to convert to? B. So you want to go to milli then, right? Okay, so if I want to convert this to milli, milli is what? 10 to the what? 10 to the minus 3. Do you agree? So what I'm going to do is I'm going to break this 10 to the minus 4 that I've got right here into a 10 to the minus 3 and anything that might be left over, right? So right now I got 7.50 times 10 to the minus 3 times 10 to the minus 1. Do you agree that that's the same number that I had before? Yeah? And meters is the unit I've got. So now I can directly replace this 10 to the minus 3 right here with milli, with that little m. Do you agree with that? Because that's what it means. So this becomes 7.50 times 10 to the minus 1 millimeters. Do you agree with that? But now what does 10 to the minus 1 mean? Doesn't that mean divide by 10? So this becomes 0.750 millimeters. So that's how we make the conversion from some prefix to some other prefix. Okay? Is that the right answer? We didn't say all that, right? We just said this is how you make the conversion. So again, I don't recommend that this be the answer, okay? We'll give you about 15 seconds to sort out what the answer should be. All right, what's the prefix milli mean? How many microliters in a liter? Now we got to do just a little bit of math, but not much. How many microliters in a liter?